Hello dear students, I welcome you all to the fourth video on tangents and intersecting chords. So the first question for the day is question number 19. So let's read out the question. So in the given figure, AB is the diameter of the circle with center O. So there is a circle whose center is O and AB is the diameter. And AD is the tangent. So we see that AT is the tangent out here. So according to question, we need to find the numerical value of x. That is, we need to find this angle, that is ATB. Alright, so let's see how to do this sum. Okay, let's observe this triangle first. Okay, see, we know that AT is the tangent, right? And OA is the radius. So that's why this angle will be 90. Okay, so if you see this triangle ATB, okay, so if we know this angle, okay, if we know this angle, then we will be able to find this, because the sum of interior angles will be 180 degree. All right, so first let us quickly find how much is this angle. Okay, so in this triangle, okay, that is OBC, we see that OB and OC are the radius, right? So that means these two will be equal to each other. So if these two are equal to each other, then this angle and this angle, they will also be equal, because any two sides are equal means this is isosceles triangle. So in isosceles triangle, these two angles will be equal to each other. All right, so that's what is shown out here. Okay, so angle OBC, so this angle OBC and OCB both will be equal to each other. Now if you extend this side, then this becomes your exterior angle, isn't it? So this exterior angle will be equals to sum of the opposite interior angles. So these are the opposite interior angle, that is OBC and OCB. So that's why it is written COA, exterior COA. So COA means this angle is equals to sum of the opposite interior angles here. All right, and we know that OBC and OCB both are same, right? So that's why instead of OCB, can I write OBC? Yes, so we have OBC plus OBC is 2 times OBC. All right, and what is the value of COA? Angle COA is given to be 64, right? So from here, this 2 goes to the denominator and the value of OBC turns out to be 64 by 2, that is 32 degree. All right, so this angle is how much? 32 degree. And as I said, this is already 90 degree, right? So in triangle ABT, we have BAT equals to 90 degree. All right, okay, since OA is perpendicular to AT. OA is perpendicular to AT. Okay, so we can call this OBC as well, or you can call this ABT as well. All right, so ABT is 32 degree. So that's why we have sum of the interior angle, that is this angle plus x equals to 180 degree. So let us put the values. So BAT is 90, right? ABT is 32 and x is x itself. So from here, the value of x turns out to be 58 degree. All right, so you may pause the video to note down. Okay, let's move on to the next question. So in this question, ABCD is a quadrilateral, angle D is 90 degree. So angle D is 90 degree, as we can clearly see from the figure. BC is given to 38 centimeter. So BC, let us see where is BC. Okay, so this line, this length is 38 centimeter. DC is given to be 25. So from here to here is 25 centimeter. Okay, now in this quadrilateral, a circle is inscribed. Okay, so a circle is made inside this quadrilateral, so that each side of the quadrilateral touches the circle. That means each side of the quadrilateral is acting like a tangent here. All right, okay, so the side AB, okay, so the side AB touches the circle at point Q. All right, and it is given that QB is 27. So from here to here is 27 centimeter. So we are asked to find the radius of the circle. Now we have seen many problems of this kind already. All right, so in this case, we consider each vertex of the quadrilateral, right? And each vertex acts like external point from where you are drawing the tangents. So in other way, I can say QB, all right, so or BQ and BR, both are of same length. All right, please be careful, this 38 centimeter is BC, not BR. Okay, so we have BQ and BR are the tangents from B to the circle, so that's why they will be equal to each other, right? So BR and BQ both will be equals to 27 centimeter, right? So BQ is given to be 27, so that's why BQ and BR both will be equals to 27 centimeter. Now we know the length of BC, which is 38 centimeter. Now can we find RC? Yes, so just remove this BR from BC. From BC you'll get RC, or you can call it CR as well. Okay, so RC turns out to be 38 minus, okay, so this full is 38 and from here to here is 27, so 38 minus 27 is 11. So that's why RC or CR is 11 centimeter. Again, from C you have got two tangents, one is CR and another is CS, so that's why both will be equal to each other. So CS is equals to CR and they will be equals to 11 centimeter. Now we have DC equals to 25 centimeter, right? And we know CS, so can you find again DS? Yes, so DS will be 25 minus CS, that is 11. So DS turns out to be 14 centimeter. Now from D there are two tangents if you see properly, that is DP and DS, and both will be of equal length. So that's why DS and DP are equal and both will be equals to how much? 14 centimeter. Okay, now we know that angle D is 90 degree, right? It is given that angle D is 90 degree, that is PDS, I can call it, right? So PDS is given to be 90 degree. Okay, and we know that OS is also perpendicular to this line, right? Because OS is radius and DC is what? DC is a tangent, so this is again 90 degree. Similarly this is also 90 degree, right? And at last finally this has to be 90 because this is also 90, 90, 90, right? So altogether is 270, and along with this it has to become 360 degree because it is a quadrilateral, right? So that's why this also has to be 90 degree. Now OP is radius, OS is also radius, right? So since all are 90 degree, so what happens, this also 14 and this also 14. All right, we already know that DS is 14, so this is also 14, so this also 14, this is also 14, so that means the radius turns out to be how much? 14 centimeter. All right, so you may pause the video to note down. Okay, so in the next set of problems, we'll make use of one of the special theorem, and we call it alternate segment theorem. Okay, so before we begin with the sum, let us first quickly understand what is the meaning of alternate segment. Okay, so I hope you are familiar with the word segment, right? So the statement is given here. So let's leave the statement for now. Let's understand the meaning of alternate segment theorem. So for alternate segment theorem, what you're going to do is you will take a circle. Okay, so you will draw a tangent. Okay, so name of the tangent is xy. So let me call the point of contact to be P. Okay, so from P I am taking one chord. Okay, chord means you have to take a line within the circle. Okay, and I have taken the chord to be PQ. Okay, now whenever you draw a chord, what happens is a chord divides the circle into two segments. The bigger area is called major segment and the smaller area is called minor segment. Okay, so that's why it is called alternate segment theorem. Now according to statement, an angle between the tangent and a chord through the point of contact. So that means angle between the tangent and the chord at the point of contact, that is this. Okay, so basically we are talking about this angle between the chord and the tangent, that is QPY. Okay, so this QPY will be equals to, okay, is equal to the angle in the alternate segment. See, we are finding this angle, right? So this angle belongs to this segment, right? So what is the segment which is alternate to this? So the segment which is alternate to this segment is this one, right? So here we have to form any angle. Okay, so you have to choose any one point on this circumference and you have to form the angle. Okay, so in this case I am choosing this point and I am forming this angle. Okay, so this is the angle formed in the alternate segment. So that means this angle, okay, angle between the chord and the tangent, that is this angle, will be equal to the angle in the alternate segment, that is angle in the alternate segment is this, right? So let me give it a name and let me call it R. So basically QPY, that is this angle, will be equals to PRQ, that is this angle. So that's what is the meaning of your alternate segment theorem. Okay, now just imagine if this is your chord. Okay, so if this is your chord, then this angle, okay, so the angle between this chord and the tangent is this one, right? That is RPX. Now to calculate RPX, now this angle is belonging to this segment, right? So go to opposite, okay, so alternate segment, take any one point, okay, and form the angle, that is RQP, right? So this angle and this angle, they will be equal to each other. Alright, so this is the meaning of your alternate segment theorem. So you may pause the video to note down the theorem. Okay, so having understood alternate segment theorem, let's move on to question number 21. So in the given figure, PT touches the circle with center O at point R. Okay, so PT is a tangent which touches the circle with center O at R. Diameter SQ is produced. So this SQ is the diameter, and when it is produced, this produced line cuts the tangent at point P. Okay, now it is given that SPR is x degree. So SPR means we are talking about this angle. So this angle is given to be x, and QRP. So let us see, this is QRP. So that is this angle. Alright, so this angle is given to be y degree. So we need to prove that ORS, angle ORS is y. Okay, so ORS means we need to calculate this angle, and this angle will be equals to y degree. So that's what we need to find, okay, or we need to prove that. So write an expression connecting x and y. Alright, so that we'll see later on. So let's quickly see the first part. Okay, so according to solution, it is said that QRP and OSR is equals to y. So let us see where is QRP. So QRP means this angle. Okay, so this angle will be equals to OSR. Okay, so basically what is QR? QR is what? QR is a chord and PT is a tangent, right? So there is a segment being formed here, right? So this smaller segment, that is minor segment, and in the rest of the circle, this is called major segment. Okay, so QRP. Okay, so this angle will be equals to angle subtended by QR in the major segment, that is QSR, right? So that is this angle. Okay, so this angle and this angle, they will be equal to each other. All right, so that's why QSR, or you can call it OSR as well. So this angle and this angle, they are equal. All right, and we already know that this is equals to y. So that's why QRP and OSR both will be equals to y. Why? Because angles, they are angles in the alternate segment. All right, okay, now we know that OS and OR are equal, right? So OS and OR, they are equal. And what is our aim? Our aim is to find angle ORS, right? So angle ORS means we need to find this, right? Now this and this being equal means triangle ORS is an isosceles triangle. And in isosceles triangle, we have this angle and this angle, they will be equal to each other. So that's why we have ORS and OSR equals to each other. And what is the value of OSR? We already seen that OSR is y. So that's why ORS will also be y. So that's what we need to prove. So first part is done. So let's quickly have a look at the second part. Okay, now we know that OQ and OR both are radii, right? So OQ and OR, they are radii, right? So we can say that, see here carefully. All right, so we can say that if this and this are equal, then again OQR is what kind of triangle? It is again isosceles triangle, where this angle, that is OQR, and this angle, that is ORQ, they will be equal to each other. All right, now this will be equals to 90 minus y. Okay, y, let us see. Now we know that how much is this? This is y, right? And we know that OR is perpendicular to this line, that is tangent. That means I can say this full angle. All right, so from here to this will be 90. And how much is this? This is already y. So the remaining, this one will be obviously 90. Remove this y, that is 90 minus y. All right, so ORQ will be 90 minus y. So that's why OQR will also be 90 minus y here. Is that clear? Okay, so since OR is perpendicular to PT, as I said here just now. Now let's have a look at triangle PQR. Okay, so PQR. Okay, so in this triangle, what happens is this acts like your exterior angle, and we know that this exterior angle will be equal to sum of the opposite interior angles, right? So that's why we have exterior OQR. So OQR is exterior, will be equals to opposite interior. So this is one of the angle and this is one of the opposite interior angle. This is x and this is how much? This is y. So that's why this exterior angle is x plus y here. All right, so let me call this as equation 2, not 1. All right, so from 1 and 2, what we can say is, see here, this is OQR, this is also OQR. So that means this angle and this angle, they must be equal to each other, right? So x plus y is equals to 90 minus y. So get this y out here, so it becomes plus. So y plus y is 2y. So x plus 2y will be equals to how much? 90 degree. So that's what is the relationship between x and y. Okay, so this is the expression connecting x and y. Okay, so you may pause the video to note down. Okay, let's move on to the next question. So in this question, PT is a tangent to a circle at T. So PT is a tangent. Okay, so PT is a tangent, and if ABC is 70 degree, so ABC means this angle is given to be 70 degree, and ACB, so ACB means this full angle. All right, so this whole angle is given to be 50 degree. So we need to calculate these angles. So the first angle is CBT. Okay, so if you see here, this is given to be 90 degree. Okay, so this is not mentioned in the question, but it is clearly saying that this angle has to be 90 degree. Okay, so let's begin. So before I start doing, let me construct here. Okay, so I am joining A and T, that is AT, and I am forming a line BT. Okay, so join AT and BT. Okay, so for the first one, we can say TC is the diameter of the circle. Okay, so TC is the diameter, right? So if TC is the diameter, then what is the meaning of this? CBT has to be 90 degree. Why? Because this is angle in a semicircle, right? So TC is the diameter, so this becomes your semicircle, right? And we need to find what? CBT, that is this whole angle, and this whole angle becomes your 90 degree because this is the angle in a semicircle, which we have learned in our circles chapter. Okay, so we have found our first answer. So let's move on to the second, that is BAT. So let us see where is BAT. So BAT means we need to calculate this angle. Okay, so we know that CBA, right? CBA or ABC is given to be 70 degree, right? So CBA means this angle is given to be 70 degree, right? And what is this full angle? This full angle is your 90 degree. Please remember that. So we have ABT. Okay, so ABT means this angle. So this angle will be how much? So this will be 90 minus this, right? That is 70. Okay, hope you are understanding. This is 90 and this is my 70. So 90 minus 70 gives me this angle, that is equals to how much? 20 degree. Is that clear? Okay, now angle ACT and ABT is equals to 20 degree. How? Okay, so ACT and ABT will be equal to each other, and that will be equals to 20 degree, because if this is a chord, then it is forming two angles in this segment, that is ACT and ABT, and we know that angles in the same segment are equal to each other, and this is already 20 degree. So that's why we say they are angles in the same segment of the circle. Okay, so this also we learned in the circles chapter. Okay, so let us see what is TCB. Okay, so we have TCB, that is this angle. Okay, so this angle will be how much? This angle will be this full angle, okay, minus this much, right? And how much is this ACB? ACB is given to 50. And how much is this? Just now we found that ACT is how much? ACT is 20 degree. So that's why we have 50. This full angle is 50 minus 20. That is 30 degree. Is that clear? Okay, so we have found TCB. Alright, so that is this angle. Okay, so we can say again TCB and TAB both are, see here, this TB is forming two segments. This is smaller and the rest of the segment. Okay, and this TB is forming two angles in this bigger segment. One is TAB and another is TCB. Again, they will be equal because they are again angles in the same segment. All right, and we know that TCB, just now we showed TCB is how much? 30 degree. So that's why this TAB will also be how much? 30 degree. So our aim is to find BAT, right? BAT means this angle, or you can call it TAB as well. So what's the answer for me? So angle BAT turns out to be, this angle turns out to be 30 degree. So this is my second answer. All right, so the last part is APT. Okay, so we can say BTX. See here carefully. Now BTX is this angle. Okay, this is the angle formed by the chord and the tangent, right? And here we make use of something called alternate segment theorem. Okay, so in this segment, okay, so in this segment we are finding BTX, right? So this BTX will be angle in the alternate segment. So TB is making this angle or this angle, and we already know the value of these two, which is how much? 30 degree. So that's why this will also be how much? 30 degree. Okay, so we have PTB. Okay, so here you need to write angles in the same segment. Please remember that. Okay, so PTB. So we have, you need to write angles in the alternate segment. So PTB. So let us see, where is PTB? So PTB means this angle. All right. So we are talking about this full angle. So this full angle will be equals to, see here, this is straight line, right? So which is 180 degree, and if I remove this, that is 30 degree, I'll get this full angle, right? So that's why 180 minus 30 is 150 degree. So this full angle is how much? 150 degree. And our aim is to find what? APT, right? Now let's look at this triangle, that is PTB. So we have PTB triangle, right? So in this triangle we have sum of the interior angles will be 180 degree, right? And we don't know APT. Please remember that we don't know APT, but do we know PTB? Yes, just now we showed it to be 150 degree. And do we know ABT? ABT we have already found, right? So ABT turned out to be 20 degree. So let us put the values. So from here APT turns out to be how much? 10 degree. Okay, so the value of angle APT is 10 degree. I know this is going to be quite difficult, but once you understand and once you try the very same sum without looking at the sum, then it becomes very easy for you. All right, so I suggest you to just first listen to the video, understand and practice the very same problem by yourself. You may pause the video to note down. Okay, so there are two questions left, so quickly have a look at them as well. So question 23 says, in the given figure, O is the center of the circumcircle ABC. So circumcircle means if a circle entirely covers a triangle, okay, and the vertices of triangles should exactly lie in the circumference of the circle. So such kind of circle is known as circumcircle. So tangents at A and C, okay, so tangent at A means this tangent and tangent at C means this tangent, so they intersect at point P. Okay, so it is given that angle AOB is 140 degree. So this angle AOB is given to be 140 degree, and APC, so let's see where is APC. So APC means this angle is given to be 80 degree. So we need to calculate angle BAC. So that is this angle, that is this. All right, okay, so let us join O and C here. Okay, so join OC. So therefore we can say PA Okay, so PA and PC, this is not PA and PA, so PA and PC are the tangents, right? Okay, and we know that this OA will be perpendicular to this tangent, right? And this radius OC will also be perpendicular. So I can say that this angle, okay, so this angle and this angle will be equal to 90 degree each. And we know that sum of the angles of a quadrilateral is again 360 degree, right? So if you see PAOC, all right, so if you see this quadrilateral, we know this angle, we know this angle, we know this angle as well. So can't we find this angle? Yes, so we can find this angle. Okay, so we know that this is 90, this is also 90, so already 180 is done. So that means this angle plus this angle will be 180 degree. All right, so we have APC, that is this angle, plus AOC, that is this angle, will be 180 degree. Put the value of APC, so from here AOC turns out to be, that is this angle turns out to be how much? 100 degree. Now we know this angle as well, right? So what is the sum of AOB, AOC and BOC? So this gives me full circle, right? So the value of their sum will be again 360 degree. So we can say BOC, see, we know this angle, we know this angle, so we want to find BOC. So BOC will be how much? So it will be exactly 120. This is 140, this is 100, so together is 240. So along with this it has to be 360, so that's why this has to be 120 here. Okay, now if you see the arc BC, okay, so this arc BC subtends angle BOC at the center, and in the remaining part it subtends BAC, which we need to calculate, right? So I can say that BAC will be half of BOC, right? So that's why we have BAC is half of BOC and BOC is 120, right? So from here this turns out to be 60 degree. So you may pause the video to note down. Okay, let's move on to the last question for the day. With this we close the exercise as well. So in the given figure, PQ is the tangent to the circle at A. So PQ is the tangent at point A. AB and AD are bisector. Okay, so AB is the bisector of CAQ. So CAQ is this. So AB bisects this angle, that is this angle and this angle, they will be equal. All right, and similarly AD bisects PAC. So PAC is there and AD is here. So that means this angle and this angle, they will be equal to each other. Now one more thing is given, that is BAQ. So BAQ is 30 degree. So let us see where is BAQ. So BAQ is 30 degree, right? So we need to prove that BD is the diameter. So to prove BD is the diameter, it's enough to show that this angle is 90 degree, because this happens if BD is the diameter, right? So if BD is diameter, then this becomes your semicircle and this automatically becomes your 90 degree. All right, so in order to find BAD, or in order to prove that BAD is 90, let us find this angle BAC, that is this angle and this angle. All right, and we already know the value of this. Why? Because we know that this angle and this angle, they will be equal, because AB is the bisector. So this is already 30, so that's why this will also be 30. Okay, so that's what is written out here. Okay, now can I say this full angle will be equals to, see here carefully, can I say this full angle will be double of this? Yes, because this is this whole angle and this angle. All right, so this will be just half of this, so that's why this is 30 and this is also 30. All right, so altogether this is how much? CAQ is again 60 degree altogether. All right, so we have, if you see, PAC means this angle, right? So this full angle plus this angle gives me a straight line, right? So that's why the sum of these two will be 180 degree, because they forms a linear pair here. Now we know that CAQ is 60. So what is the value of PAC? So PAC turns out to be, this full angle turns out to be how much? 120 degree. And we want to find the value of this angle, right? So this angle will be just half of this, isn't it? Because AD is the bisector. So this angle will be again 60 degree. All right, so CAD. So CAD means this angle is 60 degree, and we already know this angle is 30 degree, right? So now we can say BAD as this plus this, right? That is 90 degree, right? So BAD or DAB turns out to be 90 degree. So we showed that this is 90 degree. So this means that BD is your diameter. All right, so this closes our chapter on our exercise on tangents and intersecting chords. So tomorrow we'll meet with a fresh exercise, that is exercise 18b. So you may pause the video to note down. Thank you very much.